Hey there. How are y'all doing, Lorenzo? Doing good. All right. So let's talk about this week and next week. Um, as a reminder, we don't have any classes Friday. That's SBC fall break. So no classes Friday. I'm spending today and Wednesday to talk about assignment 13, quadratic functions and synthetic division. And then next week, um, we have our exam. Wednesday we'll review, or excuse me, Monday we can review, and then Wednesday, Friday will be our exams, part one and part two. I put the review for Unit 2 up in basically there's three locations that you can find it. You can find it either by, let's just take a look at this, where you can find that review for, you see that? Alright, let's log in. Where can you find a review? So, course contents. Alright, so this is week 7, so you can find the review in week 7, Unit 2 review. You can also find it in the week 8 folder, Unit 2 review. I guess I got two of those there. Just remove one, delete. And you can also find it in down here at the very bottom, unit reviews. You can find Unit 2 review. So what I suggest that you do is you start looking at the review for Unit 2 now. Open a new page. Start looking at the review for Unit 2. Again, the number of questions does not necessarily reflect the number of questions that you'll see on the exam. Rather, this is a good spread of the type of questions that you will see on the exam for Unit 2. So start looking at it now, and we will spend Monday next week discussing your questions, order review, things that you want to talk about, and then we'll have our exam on Wednesday and Friday. So today is all about your questions over assignment 13, and a question was brought up in the last class, and I wanted to demonstrate something. And anyways, it took more time than I wanted because I forgot to do one thing at the end. And it also revealed a typo in the assignment key. So if you look at the key for this week's material in week 7, you'll notice that I have in assignment 13, you'll notice that I have a assignment 13 key revised. We have a revised key because there's one typo there, and I want to show you what that one typo is. And that one typo that I'm referring to is problem number 6, and that one typo was in the vertex form. And the original key did not have this 2 in front of our x minus 7 fourths squared. You must have the 2 right there. And so this is where I want to take control for today, just for a moment. I want to show you how we can go from this form into the vertex form. I want to show you the correct way to get there, and that way you can use the vertex form to answer questions like what's the vertex of the parabola, and maybe even do some evaluating with f of x. So just follow along with me. I want to take some time. I want to take a look at problem number 6. F of x is equal to 2x squared minus 7x minus 4. And what I want to do is I want to show you the two ways to find the vertex. Two ways to find the vertex. The first method involves going through and finding negative b over 2a and then evaluating the function at negative b over 2a. This is how you go through and find the vertex. This is how you can find the vertex of any quadratic function. So let's start off by doing negative b over 2a. So that's going to be the opposite of negative 7 over 2 times 2, which that's going to become 7 over 4. This, ladies and gentlemen, is the x-coordinate of the vertex. That's our x-coordinate. Now what we want to do is find the y-coordinate. And the way that you find the y-coordinate is you evaluate the function at the x-coordinate. So we're going to go through and find f at 7 over 4. So we're going to plug in 7/4 for every single x in our function. So we have 2 times 7/4 quantity squared minus 7 times 7/4 minus 4. Now, I want the fraction form of this answer. I don't want the decimal number, and I don't want the mixed number form. I want the improper fraction, because we're going to get an improper fraction here. So 7/4 squared, that's going to be 49 over 16. 7 times 7/4 is going to be 49 over 4 minus 4. The 2 up top will divide with the 16, so we get now 49 over 8 minus. Now at this point, I'm going to go through and I'm going to make every denominator be an 8, because I want to combine these like fractions together. So we'll take the 49/4 and we'll multiply it by 2 over 2. So that's going to give me a 98 over 8. And we'll multiply the 4 by an 8 over 8. That's going to give me a 32 over 8. 49 minus 98 is a negative 49 over 8 minus 32 over 8. And that's going to give me 49 plus a 32 is going to be an 81 over 8, negative. And that's the y-coordinate of our vertex. So this means that our vertex is, the x-coordinate is 7/4, and the y-coordinate is a negative 81 over 4. Now, when I say find the vertex, this is the format that I want it in. That's the format that I want it in. Now, when it comes to graphing, yeah, you want to think about changing these values into decimal values. So that's going to be a 1.75 and then a negative 20.25. when it comes to graphing, yeah, this is what you want to use to graph so that we can get an accurate graph. But when it comes to finding the vertex, when I say what is the vertex of this parabola, this is what I want to see. So, like I said, I wanted to show you two ways to do this. So the second way, and this is where I discovered the typo and where I kind of fumbled things along for that first class. So now that I know my error, now I can fix it. The second method that we can use to find the vertex is by rewriting in the vertex form a times x minus h quantity squared plus k, and we do this by completing the square. Okay, so let's begin. This is what I want to show you. We start off with our equation, 2x squared minus 7x minus 4, and we're going to go ahead and set it equal to 0. Now, to complete the square, we want to first of all, well, there's two things that you could do. You could either get the constant over to the other side or get rid of the coefficient of 2, because we want a coefficient of 1 in front of our x squared. So I'm just going to go ahead and go through and divide everything by 2. So it's going to give me x squared minus 7 halves x minus 2 is equal to 0. And now I'll move that negative 2 over to the other side. And this is going to be set now equal to positive 2. Now, before I move on, I want to highlight something. There we go. We're going to have to undo this division by 2, because that's changing the coefficient in front of the x squared. We're going to have to remember to undo the division by 2 that we just did. So I'm putting a little exclamation point out here to the side to remind myself, oh, I divided by 2, now I'm going to have to do something with it. So let's move on. Back over here to our problem. At this point, this is where we want to add the b over 2 quantity squared to both sides. So let's take a quick moment. B over 2 quantity squared is going to be equal to a negative 7 halves all over 2 quantity squared. That's going to come out to be negative 7 halves divided by 2 is going to be a negative 7 fourths quantity squared, which is then going to be a 49 over 16. And this is what we're going to add to both sides. So we have x squared minus 7 halves x plus 49 over 16 is equal to 2 plus 49 over 16. Okay, so this is where we get to factor. And again, I've stressed this before with completing the square. All you got to remember is that you're going to be adding the b over 2. What was b over 2 before you squared it? It was negative 7 fourths. So we're going to put a minus 7 fourths. And we're going to square that expression. And that's the factored form of this guy up here. And you can test it out for yourself. Go through and do x minus 7 fourths times itself and verify for yourself that it comes out to be this expression. Now back over here, I got to do some work, because we want to combine these together, but notice that we have a fraction, so I'm going to multiply this 2 by a 16 over 16. So that's going to give me 32 over 16 plus a 49 over 16. So we have x minus 7 fourths, quantity squared, is equal to 32 plus 49 is an 81 over 16. Now, to get it into the vertex form that I have written right up here, we want everything on one side of the equation. So I need to come over down here and put a minus 81 over 16. And this is where I got mixed up in the last class. Because you'll notice if we compare this to the vertex form, a times x minus h quantity squared plus k, h is the 7 fourths. That's our x coordinate, which matches what we have up here. Up here we got 7 fourths as our x coordinate way up here, so that's good. But the problem is I have a minus 81 over 16, whereas I got a negative 81 over 8 for my y coordinate up here. So this is what the problem that it took me a while to recall. How do you fix this? Because we obviously have a discrepancy between our y coordinates. And this is where you got to remember about what did you do? You divided by 2, so we have to undo that division by 2. So since we divided by 2, what we got to go through now and do is we got to go through and now multiply by 2. So that 2 is going to go to this quantity squared, and it's going to go to this 81 over 16, and this is what you're going to get. 2 times the x minus 7 fourths quantity squared is equal to 2 on top is going to divide with the 16. That's going to give you, not equal to, minus 2 on top divides with the 16, 81 over 8. And now we have our k is equal to negative 81 over 8, which matches what we had right over here. So there's another important reason why we have to include the 2. I'm going to just briefly well, I guess I just show you the whole thing. This vertex form, if you multiply everything back out, you're going to want to find that it gets back to your original equation of 2x squared minus 7x minus 4. So let's verify that. We're going to go through, let me just go ahead and highlight this. This is the vertex form that we want. I like the vertex form because I can easily determine what the vertex is. That's why it's called the vertex form. But if I go through and just spend a quick amount of time to expand this, let's use purple. Let's expand. 2 times an x minus 7 fourths times an x minus 7 fourths minus an 81 over 8. That becomes 2 times an x squared minus, you're going to get 14 over 4x plus a 49 over 16 minus 81 over 8. Distribute the 2, so that gives you your 2x squared minus, that's going to become a 14 over 2x plus a 49 over 8 minus 81 over 8. So that becomes 2x squared. 14 over 2 is a minus 7x. 49 minus 81 is going to be a negative 32 over 8. which that gets us to the 2x squared minus 7x minus the 30, minus 4. And that is the original problem that we had up here at the start of 6. 2x squared minus 7x minus 4. So you have to put that 2 that you divided by back into place, and you can see it real easily that we have to have a 2x squared. You have to have a 2x squared because that's what the original problem has. If I didn't have that 2x squared, if I just covered that up, then I would only get a 1x squared and not a 2x squared. So that's why we have to have the 2x squared. Alright, so I know that was a lot, but I wanted to show you two things. I wanted to show you the error by ways that I experienced within the first class, and I wanted to show you how completing the square, how to go through this process of completing the square on a problem like this where the coefficient in front of your x squared is not 1. Lesson is, if you divide through by some a to get x squared by itself, or to get a 1x squared, you have to multiply your end result by a in order to get it in the correct vertex form. So does that make sense, what I went through and did? Okay. So, let's get back to you. How can I address your questions? What are we struggling with? What do we need help with, or what do you want to just see worked out? How can I be of service to you?
Number 10.
What number? 3? 10. 10. How did I get 3 out of 10? I don't know. Alright, so do we just need to go from top to bottom? A through F? Oh, I'm looking at 3 again. Sorry, number 10. Oh man. Alright, number 3. Divide using synthetic division. Here we go. Problem number 10. We have x to the 5th plus a 4x to the 4th minus...
Can you change screens?
Yeah, good call. Minus a 3x squared plus a 2x plus a 3, and we want to divide this by x minus 3. Now, I don't know what issue you're going to have, but I'm going to tell you one of the most common issue that I experience in a problem like this is we got to put a placeholder in place. And do you notice that we have x to the 5th, x to the 4th, we skip x to the 3rd, there is no x to the 3rd, and we go x squared, x, and then our constant. What you have to do is you have to recognize, oh, I'm missing something, I'm missing an x to the 4th, so we're going to think about inserting a 0x to the 3rd as a placeholder. So when you go through and set up your synthetic division, let's talk about the inside of the box. We're going to have the coefficients of 1, 4, 0, negative 3, 2, 3. And remember, we're going to be dividing by a. So I'll think about this as x minus a, and we want to put a right here. So what is a? A is going to be a 3, not a negative 3. Or another way to think about this, what's the opposite of negative 3? It's positive 3. And now we can proceed with our synthetic division. So we'll bring down the 1. Then 3 times 1 is 3. We'll add and we get 7. Then 7 times 3 is 21. We'll add and we get 21. Alright, we're getting into some days I'm just kind of tired and lazy, and but this is a negative or a positive 63. So that's going to add together to give me 60. And then we get 180. Add those together, you get 182. And then 182 times 3 is going to be a 546. I used my calculator there. I'm going to add, and that's going to be a 549. So remember what this all means. If this was our x to the 5th, you drop a degree. So this is our x to the 4th, x to the 3rd, x squared, x, our constant, and this will be our remainder. So how do we write our final answer? We write it as this: x to the 4th plus a 7x to the 3rd plus a 21x squared plus a 60x plus a 182 plus a 549 divided by, and what did we divide by? We divided by x minus 3. So, if you don't mind, would you tell me if was there an error? Were you doing something and you were getting the wrong answer? Would you mind telling me what that was?
I added wrong.
I didn't catch that.
I added wrong.
Oh, yeah, added wrong. Yeah, that could be another mistake, adding wrong. So, did you put the placeholder of 0 in place in your original work?
No. No.
Good, good. Yeah. Um, in your adding, did you think of that as a positive 3 instead of a negative 3?
Yes, sir.
Yeah, that'll do it. Mind your signs. Mind your signs. Okay, what else can we look at?
$16, please.
16. So, we have the function f of x x to the 4th plus a 5x to the 3rd plus 5x squared. And we want to use the remainder theorem to find f at 3. So I need a quick refresher, so let's go look at our notes. Let's just go to our notes. Okay. Remainder theorem. If a polynomial f of x is divided by x minus c, then the remainder is f at c. Okay, so here's the idea. If we divide by x minus 3, then the remainder is f at 3. That's the idea here. So this is just a nicer way to go through it and evaluate a function. Instead of plugging in 3 for every single x I see up here, we're just going to go through and do some synthetic division. So there's our 3. Let's put in our coefficients. 1, 5, 5, 5 minus 6. And here we go. Bring down the 1. Get 1. 1 times 3 is 3. Add those together, you get 8. 3 times 8 is 32. Plus 5 is 37. And then times 3 is going to be a 111. That's going to be a 116. 116 times 3 is going to be a 16.
Sir,
Yes.
isn't 3 times 8 20?
I'm sorry, what?
Isn't 3 times 8 24?
Yeah, because I was looking at my numbers and I was looking at the answer and I'm like, something's wrong. And so there it is right there, 24. So that's 24. Add those together, you get 29. 29 times 3 is going to be an 87 times 3, or plus 5. That's going to be a 92. And then 92 times 3 is going to be a 276. Add the negative 70, add the 6 together, that's going to be a 270. And so we know, we've been doing this enough now to know that this is our remainder. So this theorem states that the remainder is going to be the function evaluated at 3. So that means that f at 3 is 270. And you could verify it for yourself if we just come up here, and I'm not going to bother to write this all out, but let's just take a look at it with our calculator. We're going to do 3 to the 4th. So there's 3 to the 4th plus 5 times 3 to the 3rd plus 5, plus 5 times 3 squared plus 5 times 3 minus 6. So there I typed it all in, and we get 270. So, the nice thing about this remainder theorem is this: if you're stranded on a desert island and you got to do this work and you don't have a calculator with you, um, then I think this math might be a little bit easier to do than this math over here. All right, what else can we look at? What else can we look at?
Can we go over number 5?
Number 5. Do we need to look at the whole thing?
Yes.
Okay, f of x is equal to x squared plus 3x minus 10. So the first question is, what is the vertex? So again, you could go through and do the negative b over 2a, the function evaluated at negative b over 2a. I don't know, I feel like redeeming myself. I'm going to go through and do the vertex form. So we'll set it equal to 0. We will get that 10 to the other side. I'll think about what is b over 2 squared. That's going to be 9/4. Is that right? b over 2, yep. Equals 10 plus 9/4. So this is the factor form of this is going to be x plus 3 over 2, quantity squared. And then over here, I'm going to rewrite 10 as 40 over 4. So that becomes 49/4. So our vertex form is x plus 3 over 2 quantity squared minus 49/4. So that tells me that my vertex is 3/2, comma, negative 49/4. Sorry, that's a negative 3/2 because Again, you gotta compare it to x minus h quantity squared plus k. So there's our vertex. Now we want to graph. B. We want to graph. Now, before I graph, I want to know a few things. I want to know what the y-intercept is. To find the y-intercept, we're going to evaluate the function at 0. This is perhaps make this the easiest thing in the world to do. Plug in 0 for all your x's. Well, those cancel out, those go away because they're just 0. And we get negative 10. So we have a y-intercept at 0, negative 10. And then the other thing that you want to do is you want to know what are the x-intercepts. And to find the x-intercepts, we need to solve f of x set equal to 0. So my first thought is this: does this factor? Are there factors of negative 10 that add up to 3? Well, yes. How about an x plus 5 times an x minus 2? If that's set equal to 0, then by using our zero product principle, we get x is equal to negative 5 and x is equal to positive 2. So we have x-intercepts at negative 5, 0, and then 2, 0. Alright, so I think I can use this information to graph. I think I'll come over here. I think this will give me enough room. So, let's just go ahead and start plotting some points. We have a y-intercept at negative 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 10. I have x-intercepts at negative 5 and 2. So 1, 2, 3, 4, negative 5, and then 2. And let's plot our y-intercept. Now, our y-intercept, we want to do a little bit of just calculation real quickly. Or excuse me, our vertex. So 3 halves, that's going to be a negative 1.5. And then that 49 divided by 4 is going to be a negative 12.25. So we're going to do our best to place that on our graph. So negative 1.5, that's going to be right here. In fact, I'll just use because we're going to want to know this later on anyways. X equals a negative 1.5. And then we want to also graph the negative 12.25, so negative 10, negative 11, 12, 12.25 right about there. So there is our vertex at negative 3 halves, comma, negative 49 over 4. Now, before I go through and try to connect all my dots, I'm going to do one other thing. I'm going to get a fifth point. And that fifth point is found by using symmetry, using our vertical axis of symmetry and this y-intercept. Since this y-intercept is, what do we say, 1.5 units away? 1.5 units away. We're going to go 1.5 units over this way. Plot a point. So again, that's 1.5 units over. And I'm going to quickly label this point. This point is going to be found at, that's going to be at negative 3, comma, negative 10. This point is at 0, negative 10. I'm going to use this information to graph. So again, it's not art class. We're just going to draw our best graph. there's a sketch of our graph. If I ask for the key points, start off with your vertex, -3/2, comma, -49/4. Then your x-intercepts, -5, 0, and then 2, 0. Then your y-intercept, which is at 0, -10, and then use your y-intercept and your axis of symmetry to get that fifth point, -3, comma, -10. So there's our graph. What is the equation for the axis of symmetry? X equal to -3/2. That's your axis of symmetry. We have a minimum. This point right here is a minimum at -3/2, -49/4. What is our domain? Our domain is all the x values that we can see on this graph. So since our graph goes all the way, graph keeps going up and up and up, and also farther and farther this way, so our domain is everything from -infinity to +infinity, but our range,
Your conference is scheduled to end in 2 minutes.
our range only goes starting down right here. That's where the y values start at y equal -10, and they go up. So our range is from -10 to +infinity. Oh, sorry, not -10. Not -10. -49/4. Because that's the minimum value. Alright, so that's all the time that we have for today's class. I am setting aside Wednesday to talk about this as well. However, I would advise that you also take a look at the review, and so if you don't have any further questions over this assignment, we can address questions from the review on Wednesday as well. So we can review for Wednesday and Monday if so long as you have completed this assignment. So if there's not anything else, I'll just plan on seeing y'all on Wednesday. Have a good rest of your week. Bye-bye.
Your conference is now over. Goodbye.